And over his talk, he will cover two aspects of security. First, the fun part, how to attack. And the second one is to how to secure iOS app from MITM attack using SSL Pinning. So, securing iOS application with SSL Pinning by Pietro Messineo.
Hello, everybody. Thank you. So let me briefly introduce myself. I'm Pietro Messineo. I'm asset manager and senior iOS dev at BlueThrone. And thanks to my friends from MongoDB, I'm also developer advocate since yesterday, probably. So let me briefly explain what BlueThrone is. Like, it's a new company, and we do acquire applications from small developers or small startups up to $2-3 million. So if you do have an application and you want to move to another project, you can just contact us, and we might be interested in buying it. So I currently wear two hats. So I'm working for BlueThrone in the afternoon, and I'm working for Purple Technology in the morning. And we, in Purple Technology, we basically create trading platforms. So if you might be interested, and I'm, of course, senior iOS developer there. So if you're interested maybe in joining us, there are some QR codes, and there are, like, of course, open positions available. So let's start. It's not like free promotion about those companies. I was doing some networking yesterday, and I picked some companies, you know, like from people with which I was speaking on, and I was just downloading one application from each of those companies. As you know, maybe some of the companies just produce only one product, some others produce multiple products. So, in your opinion, which one of those companies are using like SSL pinning? Which one are like protected by SSL pinning? Like all of them? No, right? So how many of you knows like what is SSL pinning? I mean, after reading it on the paper. All right, so yeah, quite a lot of people. And how many of you have used it in the applications? Yeah, now everybody use it. Cool. All right, so let's start. Once again, I took just one application that some of those companies developed, so maybe some others might be good, some others might be bad. So, in your opinion, LeverX is using SSL pinning? Like, raise the hands who thinks that LeverX is using SSL pinning in their application? Oh, nobody. 1, 2, 3, 4, 5. Okay, cool. So yes, LeverX is using SSL pinning. Cool. So their applications are secure. Nice. So, what about in post? How many people think that this application use SSL pinning? Everybody. You have like good and high expectations. Cool. So, sorry. Nope. All right, so let's move on. Droids on roids. How many people think that the application? Oh, sorry. Okay, so 1, 2, 3 people. Nope. Okay, let me go fast. Nope. All right, so nobody is using SSL pinning in their applications, at least, you know, in the one that I tested. Yes, I'll go for LeverX. No, I'm just kidding. You know, this doesn't mean that the company is bad or whatever. I don't want that I will be stabbed out from the door. So I'm just saying that there are ways for secure your applications. So I hope that at least after this presentation, you will implement at least those extra security layer. So what is SSL pinning? SSL stands for Secure Socket Layer. And basically, SSL certificate pinning is the process of associating host with its like certificate public key. And then once you know those host certificate public key, you can then pin it to that host. But why do we need SSL certificate pinning? First of all, because we want to protect the application against meet-em attacks, so man-in-the-middle attacks. So how does it work, this process? Like, usually you have a server. The server sends like an SSL certificate, and then there is a bad guy, like that one in the picture, that sends a bad certificate to the client, and you can do several things with it. You can basically avoid, like using SSL pinning, avoid intercepting the network traffic, or avoiding the manipulation of the data that you receive in the app itself. So how does SSL works? There is like, you have like, the client is sending like a connection request to the server, then the server listens the request, gives a response with those certificates and public key, and then the client check like the certificates and send the encrypted request, like encrypted key to the server. And then the server decrypt it and send like the encrypted data back to the client. The client receives and decrypt the encrypted data. So far, so good. But it's not really like that, because if you don't use SSL pinning, all of those things are useless, because all of those processes that we just mentioned are not existing. So which types of SSL pinning do we have? We have like certificate pinning. So this means that you store the certificate into the bundle of the application itself. So then we are comparing the certificates with the one, like the one that's stored in the bundle with the one that we receive from the website, from like the API. Or we can use like public key pinning. So it means that we extract this from the certificate, the public key, we store it as a string or whatever you want to use it, and then we compare it with the server certificate during like receiving this request. So which method to use? Of course, you can use like certificate pinning. It's the easiest, but it has some limitations. For example, it's less flexible because you have to change and update the certificates once the certificate expires. And this means like the app will not work anymore. This method is usually used in the bank application because it's the most secure, I would say. Or you can use public key pinning, that is the one that we are gonna see today, because it's like the easiest. And if the certificate expires, the public key is staying the same. So at this point, am I safe? Absolutely not. Because even though you use SSL pinning, there are always ways for avoid, like for bypass this certificate pinning. And how to bypass it? There are several ways. First of all, you can install like some specific software, for example, SSL Kill Switch or Barp Mobile Assistant. But those two tools are available only on jailbroken devices. How many of you know what is jailbreak? Wow, everybody, cool. So, it's not that common nowadays to use jailbreak, but I remember like 5-6 years ago, everybody was like crazy about jailbreak and everybody was doing the jailbreak and so on, till Apple started to stealing the tweaks and implementing in their operative system. So now we have like those cool features in our operative system, so we do not need jailbreak anymore, basically. So another way to bypass certificate pinning is using Objection and Frida. We will see very soon like what they are. Or we can use a disassembler to modify the IPA. So we disassemble the IPA and do some modification to it. And for this, we can use like Hopper or IDA. So what is Objection and Frida? Basically, Frida is a dynamic instrument that allows you to do several things. For example, like pen tests, security research, and like reverse engineering of applications. Then Objection is a wrapper for this framework and will do all the hard work for you. Basically, you have to do almost nothing. So in order to kind of use those things, you have to put the Frida gadget, like the library, the dlib, into your application. How to do that? I'm just briefly summarizing how does this works. Of course, it's much way more complicated, otherwise everybody will do it. You need to extract the IPA file. Then you have like to modify the binary in order to load the dlib into your application. Then you have to code sign the application once again with the dlib file. And after this, you have to repack the update, I mean, this new version of the IPA file. So you can use the objection, and it's doing everything for you. And then the last step is basically to install it back on the device. There is a tool, iOS deploy, that is automatically doing it for you. So actually, there is a way for prevent this bypassing of the certificate pinning. How can we do that? Because as you know, like we just said, okay, we can use SSL pinning in order to avoid man-in-the-middle attacks. But it's not completely secure because there are ways for bypass it. But actually, there are even more. There are other ways that allows you to avoid to bypass this. How? There are some tools that are obfuscating the code, like the Swift code. And it's what we use in Purple Technology, for example, as we are like trading and we are playing with money, deposit, and so on. So we want to obfuscate all the things, like all the code and some related important sensitive data. And so we do use like name of obfuscation as well as renaming methods, like in a runtime. Every build, it's changing. So it's usually not like staying the same. And this is basically only protecting against like tools that are bypassing SSL, certificate pinning. So let's come back to the SSL pinning. So how to do an SSL pinning, like how to perform this in iOS? You can do it like with URL session or with Alamo Fire, as well with the AF networking, or what we're going to see today, we can use TrustKit. What is TrustKit? It's basically an open source framework. It's very easy to use, and it's widely available for basically all the platforms. So watchOS, like iOS, tvOS. It's available on GitHub, of course, and allows you to implement SSL pinning just in few lines of code. So you don't have to struggle and implement everything manually. So why you have to use it? Because it provides a very easy way to validate the certificate. And it offers also some extra functionalities. So it can be like reporting or fallback of public keys. How to implement it? So it's very easy. First of all, you have to download the certificate, and it's like in .ser file. And you can find those certificates everywhere. Like if you open your Safari, you can just drag and drop the certificate. But I'm not gonna explain you like 100% in detail how to do that. I left in the last slide a link to a Medium article that I wrote back in 2020. So you can read it and you can follow it 100%, and you will be able to perform SSL pinning or implement SSL pinning in your applications. So after this, you need to convert this certificate into a PEM file, and then you have to extract the public key. Why you need to extract the public key? Because we just said that in this example, we are gonna show how to do SSL pinning on the public key and not on the certificate itself. There is a Python script offered by the TrustKit, so you just need to run it and specify the path of the certificate file, and it will give you the public key. And then, of course, you have to set up the TrustKit. How does it look like, the setup of TrustKit? It's something like this. You need to specify the public key, the expiration date of the certificate. In this case, I was using the API of the movie database. The second string is basically the public key, the fallback public key. It's, of course, invented. They didn't have another public key. And how does it look? The pinning validation. So basically, the most important part, the hardest part of SSL pinning. Like, how does it look? It might be super scary, you know, because nobody's using it. And here we are. Just a delegate and 2 lines of code. And here you are. You have your SSL pinning. So I don't understand why nobody uses it. I mean, I understand that it's maybe not much required or whatever, and some applications are just displaying a feed with some information, but some others are having login, are, I don't know, whatever, allowing you to pick up parcel from the things and whatever. So I don't really understand why. Just with few lines of code, you cannot protect your application. So this is like the slide in which you can get the Medium article with the guide. Well, I can see a lot of people are just scanning it. Go ahead. And I would like to show you a small demo of how to perform like SSL, in the middle attack. And I will also show you a little bit the code about SSL pinning that I implemented in one demo project, just super easy one. I'm not gonna show any application from those companies that I mentioned before. All right. So I will show you first of all. It's just a simple demo project, as everybody knows. This is like just a simple URL session data fetch. So you can see in plain text the API key, very secure, and all of those information. So it's just a simple URL session data task in order to fetch those information from the API movie database. And now I will show you how does it look the same, exactly the same request using TrustKit and protecting it with SSL pinning. Here you are. So I just moved the URL session out, and I just assigned the delegate and called the TrustKit. And in the end of our usual data fetch, it's exactly the same. We do have a delegate that is basically taking care through TrustKit of performing like the check if the public key is valid or no. So someone wants to share something with me on AirDrop. Thanks. I will save it. I don't know who is. Whatever. I'm gonna run this on my phone, and we can see what's the output. Oh no, this is my Mac. All right. And I'm gonna even like share the screen of the phone. All right. So it's a very basic application with 2 buttons. Lost connection, amazing. Spoiler, my home screen. So it's a basic application with 2 buttons. One is performing the request through the TrustKit. And if I would push fetch movie SSL, you can see here some information like TrustKit is trying to perform the public key pinning. And as you can see, SSL pin found for API the movie database, pin validation succeeded, and we got the data, so 20. 20 is like the amount of movie that we fetched. And instead, if I'm just clicking on fetch movie standard, this is the second button, it's just a normal URL session call, so you just get immediately. There is no validation, there is nothing, you just get the information. Nice, cool, but how can we be sure that this SSL certificate pinning works? So for this, I'm gonna use a tool that I'm using for this penetration test that is called Charles. Somebody knows it? Oh wow, everybody knows it, cool. Well, most of the people. So I'm gonna enable like SSL pinning on this, and I will show you what's the result after enabling it. But first of all, you just need to give me 1 second. Let me hide this. So just setting up the phone for with the proxy for Charles. Just bear with me, please. All right. So here we are. And I will also show this, but smaller. So here you can see all the networking that should going on my phone. So if I will try to push something, it should appear there, but actually it doesn't appear. All right, something is going on, but everything except for the movie database. Cool. Anyway, everything except movie database API call, even though there it's working, here nothing appears. All right, so I just wanted to show you that if you enable certificate pinning through Charles, basically the TrustKit response will be validation failed because it cannot match the public key. I'm going to show you now another actually application and how to edit on the fly the response that comes from the server. So I have this application here. And as you can see, it's having HTTP requests. So basically, you can see in plain text all the things here. It's on my server. It's just a demo. It doesn't really matter. And I'm gonna show you how you can change this response and have some real data changes on the phone itself, like on the inside the application itself. So first of all, you have to enable breakpoints, and here breakpoints. Where is the screen? And once that you enable this, we have to go here. Breakpoint settings. And here we have already this thing. All right. Get all the queries. All right. So we are ready. Let's clean this. And let's relaunch the application once again. Yeah, as you can see, we put a breakpoint. So basically, the response is not going through because we just defined that when we got that server, we want to just stop it. And we want to do something on the data that we received. So we click on Edit Request. And we can see, for example, headers, URL, text, and so on. So we can click Execute. And now the breakpoint is called once again. And in the edit response, we can see the JSON text. So basically, the response that we are going to get. So at this point, we are able to edit the response. And we can then inject into our application the new changed response. So as you can see there is nothing because actually the device hasn't received anything yet. So let's go to change the title of this movie, Jurassic World. And we will just put Hello World. And at this point, we can then click Execute. Execute. All right, my phone went in standby. Cool. Let's change it once again. Because it's just a demo, you can perform it on HTTPS without SSL pinning and enable SSL pinning, SSL pinning on Charles in order to get the response in plain text. Right. Let me kill it. You know, live demo never works. Edit response. All right, something went wrong. Sorry? Double quotes? I miss it? All right, cool. Last try, otherwise we will just... Will it be the correct one? Yes. So let's find... Thank you! So as you can see, the last movie on the right side is having the new title that we change on the fly. So, I mean, all of these mistakes and tries were just for let you understand that you can basically change the response, and it's only up to you what you can do with the response and which parameters you can change. For example, once it happened to me to find a game that wasn't having any SSL pinning, and once you open the app, the game is fetching the API time, like the current time. What can you do with that? You can change the time, and you can increase or decrease the time in order to have some extra points or extra benefits or unlock some levels and so on. Just this is simple example. And why should you use SSL pinning? I will tell you a story of a developer, not me, that developed an application. And as always, you know, we do have competitors. Competitors usually have similar or same applications that we do. And it happens that this developer developed this application a week later than one of his competitors. So being a week later means less downloads, because if it's like nice trend, then you need to kind of fit into the market. This developer wasn't using SSL pinning, but was using a private API with some daily limit quota. So what this developer did, in order to steal the downloads, just took the API key of this application, of the competitor, ran a loop, and removed all the daily quota. So all the people couldn't use this application, and they moved to the new one because, you know, it was working. Yeah, it's not me. Just an example, just saying. So that's why you should use SSL pinning. I mean, this is one of the reasons why you should use that. So thank you very much. From my side, that's all. If you have any questions, feel free to ask.
Thank you very much. So you mentioned that this is difficult to extract the API. I was trying to get the IPA, from the App Store, but I didn't get it. So do you have any advice how we can do it until we have a jailbreak on the phone, of course?
So you want to know how can you extract an IPA without having a jailbreak on the phone?
Yeah.
You can use IDA, or one of the tools that I mentioned before, like Objection and Frida as well. It's not easy, but it's possible to do that. So you can use Frida. I believe like it's the tool that suits your needs.
Okay, thank you.
You're welcome.
Okay, 4 questions.
If you have a certificates chain, which one do you use to pin in the application? Whatever, the certificate or public key from the certificate.
If I have a certificate chain,
Yes.
well, you should definitely check the expiration date of the certificate. So you should go, you know, in order. Like if you have a chain of certificate, you use like the one with the less expiring date, you know, like the one that is still valid. You're welcome.
Could you go to the slide with MIT attack on the iOS device?
Yes. This one?
With the device, like, okay, this is fine. Can you tell me how this is possible on normal iOS device to perform MIT attack when the server in the middle is signing the certificate, but by not authorized certificate authority, so the device will not accept it because it has the list of all authorized certificates authorities. So how it is even possible on iOS device?
Well, I don't know if I understood your question correctly, but the thing is that iOS doesn't have any certificates by default.
Yes, but it has like the list of certificate authorities. Like every certificate is signed by the authority. The MIT, like in the middle, has like the authority which is not authorized on the iOS, so it won't be validated.
Yes, now I understood your question. In my demo, I skipped some steps. I do have a certificate installed on my phone that allows me to perform a man-in-the-middle attack. So it's a certificate generated by Charles that allows you to do exactly this. Like
yes, but in real world, how it is possible? In my opinion, it's not, unless like some certificate authority is like compromised. But I think that Apple should have in these cases like the way to remove that from all iOS devices.
Well, I believe if you will have like a router with not proper, settings and certificates and so on, you might be able to perform it in real life as well.
Yeah, but like the validation happens on the iOS device.
Yeah, that's true. That's true. But in general, you always have to kind of protect those things because anybody can just do something like this. I understand that in a real life situation might be complicated to get something to arrive to something like this. But if you don't protect your application, then there is always a way for expose the user's data. Not in real life.
Like how?
Like
can you like?
I will just show. If I know like which is the API
yeah, but
call.
You had like the authority certificate authority installed by yourself, right?
Yes, I don't wanna really dig more into it.
But is it possible or not?
It is definitely.
Yeah, thanks. Just a follow-up thing on the previous questions. Maybe we could just store a hash on the iOS device and then have that correlated with the CA on the backend, and from there just take the actual authority. But it's just like an open thought on that. Pietro, thank you very much for your presentation and the stubbornness on the demo. It was really nice looking at that. I'm looking at the SSL pinning while using this mostly on the financial apps as a thing that is kind of like a maybe anti-pattern, as something like it's kind of an obsolete thing. When it comes to the like the modern security and the high security environment, like zero trust security framework, do you think that the SSL certificate pinning or public key pinning are the like ways that can accomplish those assumptions, or these are the things that should exist with some other tools, some other like technologies like MTLS, I mean mutual TLS, assuming the verification on the mobile side, etc. But as you said on the previous question, the MTLS is not exactly possible on the mobile world. So how do you consider SSL pinning in terms of the zero trust security framework?
Well, that's a good question. SSL pinning and those public key pinning, certificates pinning, it's at least a layer for protect your application. And as I mentioned before, it should go with it like the obfuscation of the code and of methods and so on. So this allows you to add an extra layer of security to your app. Then I don't really use anything else aside this in our trading application, that is more sensitive, more than other applications because you handle payments and so on. So I do not really know which other advice can I give you except for those two things.
Yeah, actually, I would be surprised if you have that other advice, to be honest, because I've just disclosed myself as an Android developer. Sorry for being at that conference as an Android developer. But in our world, we need to step outside of our comfort zone and learn some neighbor technologies. So I really like looking what is happening on iOS. On Google world and the Android, we actually are suggested by Google not to utilize SSL Pinning anymore because of the changes and the problems that actually were outlined by yourself and some previous questions. So yeah, we are in the moment about thinking about some other just solutions. And actually the previous questions was the thing that we are currently thinking about, utilizing the mutual TLS and then having a iOS or Android device as a like a place of storing a CA. But the storing a CA is kind of like a Purio X or at least I would consider this as an impossible thing to have that on the iOS or Android device. But there should be a workaround, like with this hash, for example. So yeah, just I'm inviting everybody for the debate and thinking about that, because SSL Pinning might turn out as an anti-pattern or something that is actually legacy simply and not sufficient for the current needs on the mobile market. So, but once again, thank you very much, Pietro.
Thank you for the question. And yes, we can start a debate, but I believe there will not be enough time. People are hungry as well. Definitely, there is a way, for avoid that user will manually accept and allow the certificates and blah, blah, blah. But this is like very hard, and it's very like a small percentage of people and companies are able to do such things. So I would say, like in real world thing, it's not like really a big issue, those certificates pinning and so on.
Hi, thank you for the presentation. As one of the former developers from one of the companies you mentioned in the beginning of the presentation, I feel kind of called out. So I would like to say something. Like we had this case where we wanted to implement SSL pinning, but we worked with a third-party company which provided the backend. And to be honest, we couldn't trust them with being conscious enough about the certificate expiration and giving us the heads up. And as far as I know, the public key pinning is not always an answer, because the public key also can change. If the certification signing request changes, the public key could be different. So do you have any advice regarding the organizational part of certificate rotation, which could help in such case where you can't really trust the backend provider with keeping you up to date by themselves?
All right. So first of all, I want to specify that the companies that I picked and that I analyzed, I haven't done it for, put them under a bad light or whatever.
Yes, of course, I'm just joking. But
it was, just to specify. Actually, usually the public key is like binded to the certificate. And if you're not issuing another certificate, but you are just, renewing it, you always have that public key. And as you saw before, you can specify multiple public keys in order to have like a fallback. So maybe the idea or the solution might be to have a list of public keys in case the certificate will expire, and that's basically it. Or you can fetch those public keys from somewhere else, but how can you protect the other side? I mean, you have to have
the chicken egg problem right now.
Yeah, more or less yes, except that the fact that you will do SSL pinning on another server in which you are just storing the public key, and you fetch them from another side, basically.
Okay, so basically manage the pinning to a server which we hold the management of, like we maintain maintenance of.
Yes, exactly. So you are kind of sure that the certificate will of course will expire, but the public key will be always the same, and the other one will just fetch the keys.
Okay, thank you very much.
You're welcome.
Any other questions?
Hey, so couple of things. For the person that was talking before about this slide, I think the problem is not so much that you do a man-in-the-middle attack on a third-party person, is that you will yourself install the certificate on your device and sniff the traffic, and then be able to know how this app is communicating and exploit it. So if you have a banking app, if you have a trading app, of course, yeah, you have to install the authority on the phone, but that's exactly what you were doing on the screen. So I believe the risk is that, not so much that somebody's going to do a man-in-the-middle attack on somebody else. And the second thing is, if you pass to the next slide, could you do that?
Sure.
Where you extract the IPA from the phone, you have
All right.
to decrypt it, right? You have to get it from runtime.
Yes.
Fair enough. Okay.
This one.
Yeah, exactly. Extract the IPA basically means you get it from runtime, decrypt it, and then run it decrypted.
Yes.
Okay.
Yes.
Super.
Thank you. Anyone else? Looks like not. And congratulations, your presentation had the most emotional discussion ever.
Thank you very much.
Thank you, Pietro.